So let's take look at an example here of the mean value theorem in action. I want to consider this function x minus 4 quantity squared plus 3, and I want to find all values of c. So this is not just using mean values theorem to say do they exist. It's saying once you know they exist, find them. I want to find all values of c on this closed interval 1 to 5 such that f prime of c equals f of 5 minus f of 1 over 5 minus 1, which is negative 2. So I'm looking for all values that have a slope of negative 2. Now, just quickly, we can work this thing out so you can see that this is in fact negative 2, because f of 5 is going to be 5 minus 4 squared plus 3. That's minus f of 1, which is 1 minus 4 squared plus 3, all over 5 minus 1, which is obviously 4. Let's see, 5 minus 4 is 1. 1 squared plus 3 is 4 minus, let's see what I have here, a negative 3 squared, which is 9. 9 plus 3, 12, over 4. And let's see, I'll put it right here. 4 minus 12 is negative 8 over 4. There's my negative 2. Now, produce appropriate graphs to verify your results. Okay, so first of all, let's take a look at some of the conditions that we need for the mean value theorem. Clearly, see, f is continuous and differentiable on 1, 5 and the open interval 1, 5, because f is a polynomial. Polynomials are continuous and differentiable everywhere. So we have the continuity and the differentiable. So what we need now is to show that there's the c that exists in there. And the mean value theorem simply tells us that it does exist. So now we need to figure out what it is. So what I need to do is find the first derivative. Actually, that shouldn't be 1 because I put them all together. I'm going to make this an asterisk. There we go. So now we show that the mean value theorem applies and it does exist. That's value of c that gives me negative 2 does exist. So I'm going to find the first derivative. So f prime of x equals 2 times x minus 4, which is, I'm going to leave it like that. I need to set this equal to negative 2. So yeah, you know what? I will go ahead and do it like this. So that's what it equals. So I need to set this equal to a negative 2. So I have 2x minus 8 equals negative 2. That's that slope that I'm trying to find the x value for the first derivative that will give me that slope. So that would then imply that 2x equals 6. So x equals 3. Now, f prime of 3 equals 2 times 3 minus 4, which is 2 times a negative 1, which is in fact a negative 2. So there's my value of c. The mean value theorem said it's there, it exists. We just went and found it using other techniques. Now, for me to use appropriate graphs to verify the results, I have the slope. What I need is a point so I can find the equation of the tangent line. Then I can graph the equation of the tangent line along with the original function to show that it's reasonable to begin with. So what I need is, I need f of 1. I'm going to take this first point here. So f of 1, that's the original function, is 1 minus 4 squared plus 3. That's a negative 3 squared, which is 9 plus 3. That's 12. So I have the point 1, 12. So y minus 12 equals a negative 2 times x minus 1. There's an equation, a line, that's going to run through 1 and 5. That would imply that y equals a negative 2x plus 2 plus 12. So y equals negative 2x plus 14. So that's the equation that will run through the points again, 1, 5. Now what I need to do is find the point on the graph that corresponds with x equals 3, because then I can go ahead and graph the second line to show that they're parallel. So the first function I have is y equals negative 2x plus 14. And now I need to find f of 3. And f of 3 is going to be 3 minus 4 squared plus 3. That's 1 squared, negative 1 squared, which is 1, plus 3, that's 4. So I know I have the point 3, 4. So I'll take y minus 4 equals negative 2 times x minus 3. That means that y equals negative 2x plus 6 minus 4, plus 4. So I'll get y equals negative 2x plus 10. So I should be able to graph this function and this function, and it should be pretty clear that they are in fact parallel to each other, and they touch the graph where we said they would. Now obviously they are parallel, they have the same slope and different y-intercepts. So right away I know that they're parallel. So let's take a look at a graph and see what we get. Okay, so here I went ahead and entered Maple. Here's my original function. Here's my points when x equals 1 and x equals 5. This connects those 2 points that we're talking about. And then this is the tangent line at x equals 3, which shares the same slope as the secant line for x equals 1, or connecting where x equals 1 and x equals 1. So we confirm the mean value theorem applies. And we went ahead and found the actual value c, which in this case x equals 3, that shows the mean value theorem is true. And then we went ahead and graphed all 3 functions for a visual comparison.